Okay, now let's apply dot show. We'll run this because Seaborn is not yet in this Jupyter. Currently I'm having an error. But when I copy this line of code and I make use of the PyCharm, I copy this line of code and I go to my PyCharm and run this line of code on my PyCharm. Let me quickly paste that here. Now, running the same line of code on my PyCharm. Okay. Running the same line of code on PyCharm, you can see what I'm going to get. That is going to run that particular line of code. Okay, it's giving me error here. Let me quickly work on that. Let me paste it over again. Let me run it. Let me see what it's going to give to me. Okay, now you can see now I'm running this on PyCharm, and that gives me this plot. Now this gives me this plot. Now it gives me this outputs. Now this is a logistic regression. The apply.show actually brings up this particular distribution. So let me go back to my channel. So I can run another line of code there. So let's the logistic distribution. Now, differences between logistic and normal distribution. Now, both distribution are near identical, but logistic distribution has more area under the tail, meaning it represents more possibilities of occurrence of an event further away from the main. Now, what we're saying is this. Now, this logistic distribution upon at the bottom here, most of the distribution spread to this side and to this other side. So that's what we're trying to say. Unlike the normal distribution, here, again, most of the distribution are more closer to the main value here. Is more closer to the center. But the logistic distribution at the bottom here, the length of the distribution it moves longer. The tail of distribution is longer. So that's what we are trying to say there. Okay, now like this is the normal distribution. Let's try running this. Let me try running this. Okay. What we're going to do, let's go back to our PyCharm. Okay, here I will say random dot logistic. You can simply make it random dot normal. Okay, and that gives us the normal distribution. We'll run this particular line of code. That runs it. I'm running it now on PyCharm. Now that gives me this. Now you can see there's a difference between this shape, this distribution, with the previous one that I did. Now this distribution, this is what I am getting now. You can see that this is wider here, and it's giving me the length here. So, but when I run the line of code using the logistic distribution, that is random.logistic. Having been Seaborn, this was random.logistic. Okay, random.logistic. I run this particular line of code. Let me run this one line of code all over again. Okay, now you can see this this was the logistic regression. So that gives me this shape. So now let's move on. So the difference between the logistic distribution and normal distribution, both distribution are near identical, but logistic distribution have more areas under the tails, meaning it represents more possibilities of occurrence of an event further away from the mean. For higher value of scales and the standard deviation, that remember we said the scale argument represents the standard deviation, the normal and logistic distribution are near identical for higher value of scales. This where the standard deviation is high, identical apart from the peak. Now, this is an example of another example of the logistic regression. Yeah, so we're going to from number, we are going to import this. From the import the matplotlib as this, and we're going to put now this is data. We're giving it a name. So under this data, we're saying okay, normal. Okay, remember when we're doing the different types of data type, we're talking about the list data type, the array data type. We looked at the set data type that it comes with a curly bracket. Okay, now under this we have normal distribution. We have the random dot normal. We have a scale of 2, and we're talking about the standard deviation of 2. And the sample size should be 1,000. So we're already familiar with this. So we have normal. So that this will give us a one column known as that normal. Then this is logistic, and we have another one known as logistic column to that. So let's quickly copy this line of code. Okay, let's quickly go to PyCharm. So we are going to run that particular line of code. Currently, I'm using PyCharm now. I'm using PyCharm and running this. So let's say for NumPy, import random. Okay. then import matplotlib dot py matplotlib.pyplot as ply. Import cbon as SNS. Okay. Now let's call that normal. We can call it any name. Remember that we can give that any name. So random dot normal. Random dot normal. Okay, random dot normal. We call that the scale. We give that the scale. We pass the argument scale in that. The scale argument. Pass the scale argument. Logistic. Random dot logistic. Okay, let's call that random dot logistic. We say size is equal to same 1000. Okay, now when we have random dot, we here the scale. Now by default here we are making the scale to be 0, and here we are making the scale to be 2. So we're trying to start what we see here. So now that we've gotten our data set, now this gives us a data set that creates the data set now. So now we've created the data set, let us plot. So we are going to use the cbon. The cbon is very, very good in also in plotting charts. So let's say the cbon.displot. Now we have this and this distribution and cbon.distributions. Let's pick this. So the first argument here is data. They have the X and the Y. They have other arguments. Now, the arguments you are going to use a kind argument. We have a lot of argument there. We have the row, we have the column, we have the and so on and so forth. So we are going to pick this. We're going to pass the data argument into it. That is a data. We name our data. We call this data. So I'm going to pass that into this as data into that. So that's data. I'm going to use them. Then the kind. So that's a kind argument. So the kind here, I'm going to use them. Okay, let's use that. So now we've used our zip. We've introduced our zip nodes. Okay, now with this, now we've done this. So we are going to just run this particular line of code. Okay, let's quickly cut off this and run this line of code. So that's we run this line of code, and you can see it's going to plot the data set here. Now you can see the plot that we have. You can see the logistic regression whereby we make use of a standard deviation of 0 by default. We have normal regression, which we used the a standard deviation of 2. Okay, you can see the normal, we use a standard deviation of 2, and that gives us a elliptic distribution. Now let's look at Pareto distribution. The distribution follows Pareto law 80 to 20 distribution. We have 20% factor that causes 80% outcome. That is 80% outcome is being influenced by just 20% of the distribution. That's what we talked about Pareto distribution. So where 20 factors causes the outcome of 80%. Now it has two parameters. Pareto distribution just have only two parameters, and A equals to the shape parameters, Y the size, the shape of the return array. That gives us the shape of the return number is an A number, the number size, that's the sample size, that is the size. YA is the parameter. So now we have this now. Let's draw a Pareto distribution with a shape of 2, with a size of 2 by 3, 2 rows and 3 columns. Now we are going to look at a shape of 2. We already say A here. We said A equals to the shape parameters. So that's the shape parameter of 2 with the 2 by 3. Now, it's just similar with the logistic regression and normal regression we use. We're going to use a random package, the random method we are going to use, dot the Pareto. Excuse me. Excuse me. I'm sorry for that. Okay, now I'm going to bring in my pie chart. So we're going to do from NumPy import the random. From NumPy report random. That's from NumPy package where the report random. Then let x equals to random dot Pareto. Okay, NumPy dot random. A equals to 2. Size equals to okay, now we have this. So let's print x. Now, first and foremost, let's see our data set. Let's see our data set first and foremost. Let's try to see our data set. And that gives us our data set here. Now you can see our data set a 2 by 3. It gives us a 2 by 3 matrix. Okay, that's our data set there. So if we want to plot that, we have to import the Seaborn as well. Then we import the matplotlib into it. So let's see if we want to import that. We want to plot that. you want to plot that. How do we go about in plotting it? Okay, now if I want to plot this, yeah, okay, so I'm going to import my matplotlib, import the matplotlib. Does the matplotlib pyplot as bytes, then import C1 as sim. Okay, now we've imported that. So what we're going to do now, here, random.pareto now, we're going to wrap this up. I'm going to wrap this up with the cbon. Okay, well, let's say let's cbon, import cbon as sim dot the this plot. Okay. Let's make this the size of 2. Okay, and the size of 1000. Okay. So let's make A equals to 2. Remember we said the Pareto has just 2 parameters. And we have the the A shape parameter, that the shape parameters, and the number size parameter. So let's just close the gap, but that shouldn't be a problem. Here we're going to do the blight.show. Let's run this line of code, and if everything is done properly, that should plot the chart. So this is the chart, and this is the Pareto chart that we've gotten as plot the chart we've just plotted. Now let's look at that we are done with Python NumPy. Now let's look at the pandas. Let's look at the pandas package in Python. Let's see the pandas package in Python. That's Python pandas. Now, pandas is a Python library. Pandas is used to analyze. In the Python library is used for data analysis. We can load a CSV file into the pandas list frame. So first and foremost, we have to import this. I import pandas as PD. Then we have to data frame equals to PD.read. We're going to use the read function, and this represents a file. Now, what we're going to import this into a file, we have to make sure that the file we are working on let me go to my Jupyter notebook. Here is my Jupyter notebook. Yeah.